In lesson 3.1, we are going to be talking about how division and multiplication are related. And in simple terms, they are essentially fact families. And a fact family is a group of related facts that use the same numbers, and you can use fact families to relate multiplication and division. In short, multiplication and division are opposites. Right? And that's kind of a big deal because if we go one direction in multiplication, we can go the other direction using division. So an example here, Cheryl's helping to put away 18 basketballs after practice. She places them on a rack that has 3 shelves. How many basketballs can she put on each shelf? Well, first off, make sure you look at what your factor is when you're multiplying. But then secondly, make sure you also look at what operation you're using here, right? So 3 times what? Well, 3 times 6 is 18. And so the opposite of that, because our commutative property of multiplication is that I can write these essentially the other way. 6 times 3 is 18. Again, look at your sign, your operation you're using. On the flip side of that, now we can use 18 divided by 6. So if I take what I already have and I divide by the other number, right, I can get back to my original. So 18 divided by 6 is 3. 18 divided by 3 is 6. So I'm just going the other direction when I divide. So 18 divided by 3 is 6. So Cheryl can put 6 basketballs on each shelf. So if I were to say I have 3 shelves and basketballs on each shelf, I can put 6 of them, right? So if I were to draw that out, I would have, let's just make this nice and pretty looking, and let's add orange basketball to this, right? So I can put 6 basketballs, 1, 2, 3, 4, 5, 6. And if I have 3 shelves, I am essentially multiplying 3 by 6, and in total, I will have 18 basketballs, right? 6 times 3 is 18. 1, 2, 3, 4, 5, 6, and I have 3 rows, so in total, I have 18 basketballs. Now, an equation is a number sentence that contains an equal sign, right? Equi, we talked about this before, EQUI equals equal, right? So you can use related facts to help find the unknown or a missing value. And we call those unknowns variables because they vary, right? In what they represent, right? So you can use a letter to represent that. So if I were to then look at my next problem here of saying, well, Ellie is creating gift bags for her party guests. She wants to divide 56 pencils equally among the 7 gift bags. How many pencils will go in each bag? Well, I can say P is what I am solving for, right? So if we have 56 pencils and we're dividing it based on 7 bags, 56 divided by 7 is P. And our variable, we want to make sure it relates to what we're solving for. So here, P stands for pencils. It's just helpful when you are trying to explain, the problem. It makes sense in your mind a little bit easier. So what number times 7 is 56? Well, 8. Remember, 5, 6, 7, 8, right? Multiplication is kind of like a dance. 5, 6, 7, 8. Well, 56 divided by 7 is 8. So since P equals 8, Ellie will put 8 pencils in each bag. Now we'll complete our fact family for 9, 8, and 72. So how do these relate? Well, 8 times 9 is 72. So the other way to write that would be 9 times 8 is 72. So I can say 72 is made up of 8 and 9, right? So 72 divided by 8, that is 9, right? Make sure that you're looking at the number that you are dividing by. And then 72 divided by 9 is 8. So let's now look at our other fact family here, 48. So we can first think of 48 divided by what equals 6? Well, 48 divided by Well, we can also think of it as 8 times 6 is 48. So 48 divided by 8 is 48. Oh, I'm sorry, 48 divided by 8 is 6. For 40 and 5, well, what times 5 equals 40? 8. So 40 divided by 5 is 8. So now let's look down and do some independent practice here. I'll work some of these with you. Let's change our color just to separate some of our work, right? So if I look at these paper clips, well, I have 1, 2, 3, 4, 5 paper clips, and I have 1, 2, 3 columns of them. I can say, well, a fact family would be 5 times 3 equals 15, right? And then I could say the opposite of that. Well, 3, not the opposite, but the other way to write my multiplication part of it, of 3 times 5 equals 15. So the flip side of that would be saying 15 divided by 3 equals 5. And then 15 divided by 5 equals 3. Do you see how we go one direction? Here, 3 times 5 is 15. So if I go the other direction, 15 divided by 5 equals 3. I end up back with what I started with. All right, now if I look at my next one, I have 2 columns of these counting blocks, right? And I have 1, 2, 3, 4, 5, 6, 7, 8 little blocks. So how many total? 8 times 2 equals 16, which I could also say that I have 2 times 8, and I still get 16. So to write the division part of this, how it relates would be saying 16 divided by 8 equals 2, in which 16 divided by 2 would then equal 8. Let's now look at number 6, 7, and 8. Go ahead, I want you to try to do these, pause it, and then we'll check our work. All right, so now hopefully you've done this, you have already worked it, I'm going to go through it now. So 4, 9, and 36. 4 times 9 equals 36, and 9 times 4 equals 36. So the flip side of that would be saying 36 divided by 4. Oh, let me, if I can write my division sign a little cleaner. So 36 divided by 4 equals 9, and 36 divided by 9 equals 4. For 5, 7, 35, well, we can look at this and say, well, 5 times 7 equals 35. 7 times 5 equals 35 as well. It doesn't matter the order you write your multiplication. The commutative property of multiplication, we end up back with the same product. Now division, 35 divided by 7 equals 5, and 35 divided by 5 would equal 7. And 3, 8, and 24, 3 times 8 equals 24. 8 times 3 equals 24. But then the flip side of that, the opposite with our division, 24 divided by 8 equals 3, and 24 divided by 3 equals 8. All right, so now let's fill in the blanks on some of our division and multiplication for these fact families. All right, so let's change our color, something a little different again. Let's use, we just use green. I was just going to pick green, so let's use this teal blue, right? So 64 divided by 8 is 8, and so 8 times 8 is 64. 45 divided by 9 is 5, so 5 times 9 is 45. 81 divided by 9 is 9, so 9 times 9 is 81. 32 divided by 8 is 4. 4 times 8 is then 32. 40 divided by 5 is 8. 8 times 5 is 40. Do you see how this connects? 36 divided by 9 is 7, because 7 times 9 is 36. Again, we are looking at variables, the unknown, right? So for 15, 2 times what? Remember, this is our unknown. 2 times what equals 12? Well, 2 and 6 equals 12, so m equals 6. 8 times y equals 24, the unknown y. 8 times 3 is 24. And 9 times g is 72. Well, I know 9 times 8 is 72. We'll work a few of these problems here. Orange blossoms have 5 petals, and some are the most fragrant flowers. So how many petals would there be in a group of 7 flowers? Well, go back to your problem and identify information that gives you. Each one has 5 petals. So I'm going to be saying 5 times 7 equals what, right? And so we could say how many petals? 5 times 5 petals on each flower. There are 7 flowers, so P equals 35 total petals. How many petals, P, would there be in a group of 11 flowers? So again, 11 times 5 equals our unknown, right? I'm solving for P, right? Which we could also say this as 11 times 5 equals P. Well, 11 and 5, 11 times 5 is 55. So there'd be 55 petals. And we'll look at a group of F flowers has 40 petals in all. Write an equation to find the unknown, right? So we have a group of 40 petals, right? So 40 divided by, and we remember we have 5 petals in each flower, so 40 divided by 5 equals F. We're looking for the number of flowers. See how we use the variable, the letter, to relate to what we're solving for? So 40 divided by 5 is 8, because 8 equals F, so we'd say that it has 8 flowers. Now, if we look at some of these hot problems here, can the number 12 be part of more than one fact family? Think about that. 12. Is 12 a product of other fact families? Well, yes, it can, right? Because 4 times 3 equals 12, just as 6 times 2 equals 12. So yes, a number can be part of other fact families. And then circle the equation that does not belong with the other 3. Explain why it doesn't. So if I look at 54 divided by 9 is 6, well, that's true. 54 divided by 6 equals 9. That's true. 9 times 3 is 27. That's true. And 6 times 9 equals 54. Well, that's all true, right? However, 9 times 3 equals 27. This is not part of the same fact family. Right? Because remember we had 54, 9, and 6, right? Because we can multiply or divide to get between each one of those, right? And then how do multiplication facts help me divide? Well, we can simply think of this as saying we can use the related multiplication facts to help me divide. And this will make more sense and be more helpful as we continue on with our next lesson, in which that will be actually dividing 2-digit dividends, right? So this is 3.1. Hopefully this helps. Let me know if you have any questions.